This one technique detected the afterglow of the Big Bang, helped to discover dead stars, and may have even intercepted alien communication. It may be the most underappreciated technique in astrophysics. In 1967, a Cambridge student detected a signal so precise, so mechanical, that an intelligent alien source couldn't be ruled out. Jocelyn Bell was using radio telemetry to study quasars, bands of extremely hot gas surrounding supermassive black holes. These quasars emit vast amounts of energy, so vast we can detect them from billions of light-years away. Although quasars emit light, heat, and in fact energy across the entire electromagnetic spectrum, radio waves are the primary mechanism by which we study them. Radio waves have long wavelengths, long enough to pass straight through dust and gas that would block visible light completely. As a result, they can cross billions of light-years without losing the precise signature of whatever created them. That's what makes radio so powerful for studying the distant universe, and that's what Bell was using when something else showed up in her data. Not the broad glow of a quasar, a pulse, arriving every 1.3373 seconds. Exactly every 1.3373 seconds. Nothing natural was supposed to do that. Her supervisor, Anthony Hewish, labeled the source LGM1, Little Green Men. He was half joking, but only half. And the reasoning was sound. A signal this regular, this clean, repeating with this precision, those are exactly the characteristics you'd expect from a deliberate transmission. If you designed a test to separate artificial radio from natural radio, clockwork periodicity would be at the top of the list. For several weeks, the alien hypothesis wasn't fringe, it was the leading explanation. But Bell found a second source, different pulse rate, different part of the sky, then a third. One alien beacon is conceivable. 3 in unrelated directions with no coordinated frequency, surely not. But what was it then? What Bell had found was a neutron star, the collapsed core of a dead star roughly 10 times the Sun's mass. When a star like that exhausts its fuel, gravity crushes the core into a ball about 20 kilometers across. A teaspoon of the material weighs roughly 6 billion tons, more than every human being on Earth combined. As the core collapses, it spins faster and faster. Notice how a figure skater spins significantly faster when she pulls her arms into her body. Same principle, but amplified over 1,000,000-fold. Some neutron stars end up spinning over 700 times per second. But why does this produce a periodic signal? The collapsing of the star causes its magnetic field to intensify to roughly 1 trillion times the strength of Earth's. But unlike Earth, its magnetic poles aren't aligned with the spin axis. The collapse is never that neat. Consequently, the offset poles sweep around like the stem of an unstable spinning top. Charged particles caught in the magnetic field get violently accelerated, shooting electromagnetic radiation, including radio waves, through that spinning top stem, rotating round and round like a lighthouse beam. Every time a pole sweeps past your line of sight, pulse. 1.3373 seconds later, pulse again. Not roughly, to more decimal places than most atomic clocks could verify in 1967. Pulsars were one of the landmark discoveries of radio telemetry. But in 2007, the same technique revealed something far stranger. Signals from across the universe, so powerful and so brief that for over a decade no one could explain them. And this time an intelligent alien source would be much harder to rule out. Duncan Lorimer found something in archived radio telescope data from Australia, a single pulse less than 5 milliseconds long from hundreds of thousands of light-years away. In that eye blink, it had released as much energy as the Sun produces in an entire day. Nothing in known astrophysics explained it. Lorimer published the results, but the response from the scientific community was skepticism verging on hostility. One burst, unrepeated, from years-old data sitting on a server. It could have been a microwave oven, a satellite reflection, an instrumentation artifact. For years it sat in scientific limbo. Then between 2012 and 2014, other telescopes started catching similar bursts. Each one lasted milliseconds. Each one came from billions of light years away. Each one vanished before a second telescope could confirm it. They were named fast radio bursts, FRBs, and for a decade nobody could explain them. The alien hypothesis resurfaced. Millisecond bursts of focused radio energy arriving from distant galaxies with no known natural source. It wasn't an unreasonable suggestion. Some researchers did float it, particularly for the FRBs that repeated, but the energy involved surely made that hypothesis implausible. Each burst packs roughly as much power as the sun produces in an entire day into a window shorter than a blink. Any civilization capable of that wouldn't need radio. They'd be rearranging space-time. And the bursts revealed a telling pattern. Lower frequency waves arrived a fraction of a second after the higher frequency ones. That happens because radio passing through electrically charged gas, plasma, gets slightly slowed depending on its wavelength, with longer wavelengths slowed more. The amount of delay tells you how much plasma the signal passed through, and for these bursts, the answer was far more than exists in our entire galaxy. The signals had crossed the voids between galaxies. They were ancient. Then, in 2020, something inside our own galaxy produced a nearly identical burst, but this time close enough to identify. A magnetar designated SGR 1935+2154 inside the Milky Way, roughly 30,000 light-years from Earth, fired a radio burst bright enough to have been detectable as an FRB from another galaxy. A magnetar is a neutron star, same dead star physics as Bell's pulsars, but with a magnetic field roughly 1,000 times stronger again. To put that in context, Earth's magnetic field can nudge a compass needle. A hospital MRI machine is about 10,000 times stronger. A magnetar's field is 100 trillion times stronger than that, so intense that it actually changes how light moves through empty space, splitting a single beam into two beams, traveling at slightly different speeds. The field distorts the fabric of empty space itself. When fields this extreme undergo sudden rearrangements, starquakes cracking the neutron star's crystalline crust, the energy release is extraordinary, and a fraction escapes as a concentrated burst of radio. 5 milliseconds of scream, detectable across a significant fraction of the observable universe. So, pulsars, nature's metronomes, magnetars, nature's flashbulbs, both neutron stars, both broadcasting in radio, both at different times seriously considered as potential evidence of alien intelligence, and both natural. Extraordinary, but natural. That's 2 for 2. 2 of the strangest signals ever detected, both explained by extreme physics rather than alien engineering, which should settle the question. Except it doesn't, because there is a third signal, and this one, nearly 50 years later, still has no explanation. August 15th, 1977, Ohio. A volunteer astronomer named Jerry Eman is reviewing data from the Big Ear radio telescope. One sequence of characters jumps off the printout. 6EQJU5, a signal 30 times louder than the background, concentrated in a narrow frequency band around 1420 MHz. That frequency matters. Hydrogen, the simplest and most abundant element in the universe, naturally emits and absorbs energy at exactly that wavelength. It's a universal constant. Any civilization that develops radio astronomy would inevitably discover it. If you wanted to broadcast a signal that any species with a radio telescope would recognize, that's the frequency you'd choose. Eamon circled the printout and wrote one word in the margin: wow. The signal lasted 72 seconds, exactly the window you'd expect from a point source drifting through Big Ear's fixed beam as the Earth rotated. Right frequency, right duration, right intensity profile. It has never repeated. Hundreds of targeted observations over almost 50 years have searched for it. Nothing. Two things need to be held simultaneously here. A one-time detection can't be confirmed. Science demands reproducibility, and the WOW signal offers none. Comets, interstellar gas, equipment artifacts have all been proposed. But none of them convincingly fits the signal's characteristics. Its concentration in a single narrow frequency band, its intensity, its hydrogen line frequency. The WOW signal remains unexplained, not confirmed artificial, not convincingly natural, sitting in the data, waiting. And the ambiguity points to something that isn't a failure of science, but a problem of geometry. Our nearest neighboring star is 4 light-years away. A signal takes 4 years to arrive. A reply takes 4 more. And that's the closest one. There are 100 billion others in this galaxy alone. A civilization could be transmitting right now, just not toward us. Or they transmitted a century ago, before we built receivers. Or they use frequencies we haven't checked. The silence doesn't prove the sky is empty. It proves we've barely started looking. A handful of frequencies, a single isolated point in the universe, brief windows of time, instruments sensitive only to signals aimed roughly at us with roughly the right power. And with a haystack so incomprehensibly vast, there could be needles everywhere, but they would still be impossible to find. Picture a civilization 1,000 light-years away deciding to broadcast. Unless they focus the beam, radio spreads in all directions and fades fast. Focus it, and you illuminate a tiny fraction of the sky at any moment. 1 million target stars, a few minutes of dwell time on each, and you'd revisit any given star roughly once every 2 years. The odds of our telescope pointing at the right patch of sky during the right few minutes are vanishingly small. 2 people in different cities flashing laser pointers at the night sky, hoping the beams cross. The universe could be full of transmitters, and the silence would sound exactly the same. So, has anything artificial ever been confirmed in deep space? Yes, exactly once, and we put it there. Voyager 1, launched in 1977, the same year as the WOW signal, is more than 24 billion kilometers from Earth in interstellar space. It carries a 23-watt transmitter, 23 watts, about the power of a refrigerator light bulb. By the time that signal reaches NASA's Deep Space Network, the power arriving at the antenna is roughly 10 to the minus 25 watts, a billionth of a billionth of a billionth of a watt. We detect it only because we know exactly where to point, exactly what frequency to tune, and because 70-meter dishes cooled to near absolute zero to eliminate electronic noise are instruments designed for precisely this purpose. Now flip that. If a civilization identical to ours existed at our nearest neighboring star 4 light-years away and transmitted with Voyager's power, we would not detect it. At the distances FRBs cross, our entire civilization's radio output is undetectable. The electromagnetic bubble of our broadcasts, the one science fiction loves to describe expanding at the speed of light, fades into the cosmic noise within a few light years. Nobody is hearing our television reruns. The signal is already gone. The universe has been broadcasting in radio for 13.8 billion years. Pulsars have been ticking since before the sun ignited. Magnetars have been detonating since heavy elements first formed in stellar cores. Fast radio bursts have been crossing the cosmos since galaxies began assembling. All of it natural, all of it staggeringly precise, staggeringly violent, and completely indifferent to whether anyone is listening. And the only confirmed artificial deep space signal is 23 watts from a spacecraft we launched before most people watching this were born. The question Jocelyn Bell's pulsars raised in 1967 was never really, is this aliens? It was deeper. In a universe where nature routinely produces signals that look designed, what does intelligence actually sound like? We don't know yet. Pulsars and magnetars remind us that the universe's creativity exceeds our expectations every time we think we've caught something artificial. The wow signal suggests we might recognize a real transmission when we hear one. Voyager proves that recognizing it requires knowing almost everything about it in advance. And the geometry of interstellar distance means that even if the sky is crowded with voices, the silence could sound identical to what we hear now. Deep space isn't silent. It never was. The question is whether buried somewhere in all that noise there's a signal that means to be heard, and whether 90 years of listening has been anywhere near long enough to find out. For a limited time only, we are giving out the first 3 chapters of our complete introduction to stargazing completely free. Check our page info for the link.